A very good day to our lecturer, Dr. Shaiful, and to my group member. Today, we'll be doing a presentation on assignment 1, question set A. Before that, let us introduce ourselves. My name is Austreberta Augustine, and my group member are Nick, Alia, Abrisyah binti Nikman, and Nurul, Hanan, Khaziman. In question 1, design an emitter bias network that has the following criteria, which are VCEQ equal 10 volt, PD equal 40 milliwatt, RC equal 37 milliwatt, and IC saturation equal 8 milliampere. With this criteria given, we able to relate a formula from chapter 3, which is the maximum dissipation level, which the formula is given as BC max equal BCE multiply IC. Using the formula, we learned that VCEQ is equal to BCE equal 10 volt, PD equal PC max equal 40 milliwatt. Using this value, we substitute those into the maximum dissipation level formula, and the IC will be 4 milliampere. IC is equal to ICQ, and ICQ is given as 4 milliampere. Then we able to find IBQ from figure 1. For ICQ is equal to 4 milliampere, then IBQ is 30 microampere. Then to find IB is equal to IBQ, and it will be 30 microampere. As the value of IC and IB obtained, we can find IE, which the formula is IE equal to IC plus IB, and it will be 4.03 milliampere. And also to be able to find beta, which is IE equal to open bracket beta plus 1 close bracket multiply IB. To find the value of resistor and voltages, I leave it to Alia to explain.
We will be presenting about question 1 on how we will find the voltage and resistor value. Okay, firstly, we will search about the voltage of VRC, voltage of RC. So we know that the power for RC is equal to 37 millivolts. And we know that the formula to find the power is P equal to IV. So RC is equal to IC times VRC. Just enter the value for RC and IC and rearrange the equation because we want to find the value for VRC. So VRC is equal to 37 millivolt over 4 milliampere, and we will get 9.25 volt for the value of VRC. Okay, next, we're searching for the value of VCC. Okay, we know that we will be using this circuit to find our value of VCC. Okay, the direction on this diagram is actually wrong. We'll be using the anti-clockwise direction, and we will get negative VCC plus VRC plus VCE equal to 0. That is the equation for this KVL. So we want to search for VCC. So we arrange the equation into this. VCC equal to VRC plus VCE, and just enter the value for VRC and VCE, and we will get 19.25 volt. Next, we will be searching for the value of voltage for E. So, or as we write it here, VE. So, this is the direction of our loop, and the equation that we get is negative VCC plus ICRC plus VCE plus VE equal to 0. Okay, so we want to search for the VE value, so we rearrange the equation into P into this. which is VE equal to VCC minus ICRC minus VCE. So we know that ICRC is equal to VRC. They are the same kind of thing. So just convert the ICRC into VRC and write the equation again and enter all the value that we know. So we get that VE is equal to 0 volts. That is the value for VE, 0 volt. And now we will start to search for resistor value. We will start on RE. So we know the value of VE and we already know IE value. So we can use this equation to search for RE. Just enter the value of IE and VE into the equation and we will get that RE is actually 0 ohm. Okay, next, we'll be searching for another voltage which is VB. Okay, for VB, we'll be using this KVL loop here. So we will get the equation of the KVL loop is actually negative VB plus the voltage drop here known as VBE plus IERE equal to 0. So IERE is actually equal to VE. So just convert IERE to VE and rearrange the equation back because we want to search for VB. So it becomes VB equal to VBE plus VE. And then just enter the value for VBE and VE. And we will get the value for VB, which is 0.7 volts. Next, we will be using this KVL loop here to find the value for RB. Okay, the equation of this loop is negative VCC plus IBRB plus VB. So, and equal to 0. So, just rearrange the equation into this. RB equal to VCC minus VB over IB. And just enter all the values and we will get the value for RB, which is 613.333 kilo ohm. And next, we will be searching for the RC value. For the RC value, we will use this equation which we can get in the slideshow for chapter 3. And the equation is IC saturation equal VCC over RC plus RE. And just rearrange the equation because we want to search for RC, right? So we need to make sure RC is at the front. So rearrange it and enter all the value that we know, which is VCC, IC saturation, and RE. And we will get that RC is actually equal to 2.406 kilo ohm. Then the next thing is we need to find the value for VC. We already know the IC and RC, so just use this formula, VC equal to ICRC, and just enter the value for IC and RC, which is 4 milliampere times 2.406 kilo ohm, and we will get that VC is 10 volt, and that's all.
Then as all the resistors are calculated, using the standard value resistor from Appendix 1, for RC, we use 2.4 k ohm, RB 620 k ohm, and RE equal to 0 ohm. The design of the emitter bias circuit is drawn. Thank you.
Assalamualaikum and hi, my name is Nurul Hanan and I'm gonna explain on question 2. Question 2 asks to design a clamper that will generate this output, which is positive 2.7 volt and negative 17.3 volt, which is given that voltage input is positive 10 volt and negative 10 volt. Okay, let's take a look at the answer. This is the clamper circuit design. So first thing to find is what is the type of diode that we'll need to use for this clamper circuit. Since the input given is 10 volt and generate 2.7 volt of output, I use silicon diode. Since silicon diode voltage drop is 0.7, so what we need to find now is VC, and since the difference of input and output is big, I assume that there is another voltage source in the circuit, additional voltage source. I name it as VB. Okay, to decide on the polarity for this diode is actually by try and error. I tried on positive cycle first. For positive cycle, this is the equivalent circuit. The diode will be turned on for positive cycle. To find the VB, the value for battery, another battery, is by using this green KVL over here. So negative VB minus by negative 0.7 plus V out equal to 0. So okay, we got VB 2.7. So we got the value of VB here, the battery here. We can find the value of VC. For KVL for VC is this red arrow, and the value for VC is 7.3 volt. Since that's all for positive cycle, so we got all the value needed. For negative cycle, this is the equivalent circuit. The diode will be on open circuit because the current doesn't flow through the diode. The KVL V out for negative cycle is proof that negative 17.3. So it's similar to the question given. Since it was try and error, so it is proof that the silicon diode start with positive cycle first. So that's how I answer question 2. That's all from me and my group. Thank you.